Hello and welcome to 8.3 special right triangles. There are two types of special right triangles that we are going to talk about today, and let's go ahead and jump straight into it. First one is our 45, 45, 90 degree triangle. Okay, so if you want to put the degree symbols here, that's perfectly fine. 45, 45, 90 is technically an isosceles right triangle. So yes, you could have both isosceles and right. So this is an isosceles right triangle. And when we have these special right triangles, well, this one in particular, something interesting happens with these side lengths. So I'm actually going to draw a right triangle here, and let's make this look as close to a 45, 45, 90 as possible. So I'm going to say 45 degrees, 45 degrees. I'm going to draw our square for a 90 degree angle. And since this is 45, 45, 90, like I said, this is an isosceles triangle. And when we already talked about the specific sides of them, the longest side is always across from the 90 degree angle, which is the hypotenuse. And we actually have leg 1 and leg 2. Now, what happens with a 45, 45, 90 is that leg 1 is actually congruent to leg 2 because this is isosceles, right? And that should stand to reason. So what actually happens here is no matter what, if you have, for instance, the leg 1 has a length of A, leg 2 will also have that same length. And if you actually do this equation, the Pythagorean theorem, let's do it. Let's say it's a squared plus, normally it would be b squared, but since the leg 2 is congruent to leg 1, we could actually say this is a squared again is equal to c squared. Now, here's the thing. A squared plus a squared is actually 1 plus 1, which is 2a squared, which is equal to c squared. Okay? And then, in order to get this by itself, we should square root both sides to get the c by itself, because that's the only part we don't know what it is. So if we square root both sides, we get c by itself, and we break this apart. A squared square rooted and 2, which is square rooted. And we already know what the square root of a squared is, because those cancel out. We get a root 2 is equal to c. So this is the interesting part, is that no matter what, in a 45, 45, 90 degree triangle, as long as if you have the length of a, or the leg a, then the hypotenuse is always a times the square root of 2, no matter what. Okay, so this is the theorem, or this is the main idea, is that in a 45, 45, 90 degree right triangle, it has lengths, it has side lengths. I'm going to keep it in that order. A dash A dash A root 2. So if you want to put 45, 45, 90 right above it, no matter what side lengths you actually put there, it will always be A length, and then A root 2 length. So let's do a quick example here just to help prove this. If we have 2 here, let's go 3. And we have a 45, 45, 90. Okay, so that means this has the length 3, and then this is our unknown. So that means it's 3 squared plus 3 squared is equal to c squared. 3 squared is 9. 3 squared, once again, is 9 is equal to c squared. This becomes 18 is equal to c squared. Square root both sides. And we get, break this apart, 2 square root of 9 square root of 2, or in other words, 3 root 2. So the shortcut actually works. All we have to do is take that a value, so this is our a, and then just multiply it by root 2. In this case, it'd be 3 root 2. Okay, so we see this actually works. So no matter what, if we have what one of the legs are, we could actually solve for the hypotenuse right away. And actually vice versa. If we have what the root, or if we have the hypotenuse, especially if it's in the form of root 2, then it gives us the a value right away. So we'll definitely get some practice in with this. But yeah, that is our 45, 45, 90 in a quick nutshell. The other special right triangle that we're going to talk about is a 30, 60, 90 triangle. So these are the two most common right triangles you'll encounter, especially moving up in Algebra 2, Pre-Calc, what have you. So the second one is 30, 60 degrees, 90. And it rolls right off the tongue, which is actually kind of nice. So this is a right triangle. And let's go ahead and draw this. So it's not going to be exactly like the 45, 45, 90. We're going to have a 30, and then the 60. And then obviously the 90. So there is a shortcut to this for the lengths as well. So if you remember from when we did our triangle inequalities, we talked about small, medium, long sides and how they relate to the specific angles they work with. So looking at this, now we should hopefully remember angles and sides have the relationship. So since 30 is the smallest angle, this is going to be the smallest side. Okay, 60 is the smallest angle, so across from it, or the opposite of it, is the medium side. Sorry, 60 is the medium side, medium angle, so this is the medium side. And then as we know, 90 degrees is the largest angle, so this is the largest side, or the hypotenuse. Okay, and with that said, I'm going to erase all this. There is a very, very convenient relationship that works out. 30, the opposite of 30, we'll call that B. Okay. Then, since 60 is the second largest, let's erase that again. Oh no. So we'll call this B. 60 is the medium side, so we'll call this B root 3. Okay. If you don't believe me that this is going to be the medium side, you could actually plug in these values. You could multiply value. We'll do a quick example of it. And then the last side, the longest side, is actually 2b. Okay, so if you notice, this is the nice part, is that if you have the side opposite of 30, it's actually a quick jump to find out what the hypotenuse is. Meaning, if, for instance, well, here, let's fill this in first. It is a right triangle with side lengths B root 3 and 2b for 30, 60, and 90. Okay, so if you don't believe me, you could actually try this out. If we actually do this, let's pretend b is the value 2. Okay, and then if that's the case, then our right triangle will be as follows. This is 2, this is 2 root 3, and this is going to be 4. So if we did this correctly, okay? So for the sake of it, let's say the 60-degree triangle is 2 root 3, okay? So that means we should, in our Pythagorean theorem, it should say a squared plus b squared is equal to c squared. We should do 2 squared plus 2 root 3 squared, make sure you put that parentheses, is equal to c squared. And if we did this correctly, this should be 4. So let's find out. Well, 2 squared is 4. 2 root 3 squared is, and we should distribute this in, 4 times the root of 3 squared, which is just 3, which turns into 12. And don't forget the plus sign, and we have the c squared. So 4 plus 12 turns into 16 is equal to c squared, square root both sides, and we get 16 is equal to, square root of 16, which is 4, is equal to c, which we predicted. So this does work out, okay? So the nice part about this is that if you have the b value right off the bat, or if you then you could actually quickly calculate all of the other legs and sides. Okay, so with that said, we'll do some examples in class. If you do have any questions, please let me know, and I'll